Alrighty, this time we're going to do a different example. We're going to look at as if there was friction involved. So here's a force due to effort. Okay, and we're going to have a big box. This is the force of the load. Alright, our distance of the effort. And we have our distance of the load. Okay, now let's give some data. So our force due to effort is going to be 10 newtons, and a force due to the load is going to be 90 newtons. Okay, so our mechanical advantage is equal to force of the load over force of the effort, which is 90 newtons over 10 newtons. Okay, so this machine will allow us to lift something 9 times heavier, or apply 9 times more force. Now let's check out this. So if this distance here was 100 millimeters and this was 10 millimeters, okay, then our velocity ratio is SE over SL, distance of the effort over distance of the load, which is equal to 100 millimeters over 10 millimeters, which is equal to 10. Okay, so efficiency talks about how much of your work is being converted to raise the load. So efficiency is this symbol, and it's equal to mechanical advantage over velocity ratio times 100. All right, and that'll convert it to a percentage. So the efficiency of this is equal to 9 over 10 times 100%, which is equal to 9 divided by 10 is 0.9 times 100, so it's 90% efficient. Okay, so 10% of the effort you're doing is being wasted into friction. So how do I know how much force is being wasted into friction? Because I spent 10 newtons of force to raise a 90 newton box. Okay, so let's try this. The ideal mechanical advantage is equal to my velocity ratio, right? That's with no friction. So that means that my ideal mechanical advantage should equal 9. So if I take my load, which is 90 newtons, all right, and I divide that by 9, the ideal mechanical advantage, then it should only take me, okay, then it should only take me, this is your force of the load over, okay, it should only take me the 9 newtons of force to raise it. Okay, so we can call this one the force of friction. The theoretical force. This is called force theoretical, right? That's if there's no friction. Okay, so let's finish this off. So that means that the force due to friction must equal my force that I've applied, take away the force theoretical. So 10 minus 9 is equal to 1 newton. All right, so 1 newton of force was wasted to get into friction. 9 newtons of force was used to raise the load, and the machine was 90% efficient.